All right, here we are with ellipses. And ellipses are very similar to circles. They are just kind of stretched out circles. And so I want to start by um, rewriting the equation of a circle. So if we had um, x minus h squared plus y minus k squared equals the radius squared, and we wanted to set this equal to 1, well, we would divide everything by the radius, or right, by radius squared. Radius squared, radius squared, and radius squared divided by radius squared would be 1. And so you could write the equation of a circle in this way as well. Um, and that's really what's going to be happening with an ellipse. Um, if you're looking at the equation for an ellipse, you'll see that it's all the exact same here, except for instead of radius squared and radius squared as our denominators, we have a squared and b squared. And now let's take a look at that. And so put together a little graphic here to help illustrate the point. Here's our circle. This one has a radius of 5, and so you can count out 1, 2, 3, 4, 5. And the pink line, you could even go, well, it's down 3 over 4. Hey, I know the Pythagorean theorem. That's 3 squared plus 4 squared equals 5 squared. So you can tell that the radius really is 5 here. And now for a circle, you've got your one point in the center. But for an ellipse, you're going to have two centers, if you will, called your foci. And so I went ahead and here we have an ellipse, and it's point A over here. I don't know if you can read that, but this is point A right here, and point B are foci. And what's happening is that the black line is the set of all the points that fit the equation of x squared divided by 25 plus um, y minus 4 squared divided by 9 equals 1. The center, essentially, or not essentially, but the center right here at D is at 0, 4. And so x has nothing being subtracted or added to it, or 0 being added to it. And y has 4 being subtracted because that's the y value of the center here. Now each side has been divided by kind of its radius, if you will, that horizontally, if you're going to go from the center to the edge, there's our same green line as before, and it's 5 units. So that's our x value that's going horizontally, and so the equation is being divided by that radius squared, so divided by 25. Vertically, our radius here, and again, they're not truly radiuses because or radii, because a radii or a radius is something for a circle, but the same kind of concept applies here, and it's going to be 3 units from the center to the edge, and so 3 squared is 9, and so there's our equation there. Now, from the center to the foci, um, that is that amount, so D to B, that amount squared plus this minor radius squared equals your amount from your center to your major radius squared. And we'll kind of look at that here a little bit more right now. So let's draw an ellipse that's opening up more horizontally, that's wider than it is tall. So we'll have, and actually let me draw a little bit better picture of that. If it was right along on the origin, then we're going to have, it's a little bit better, but not much. Our center is at x minus h, or our center is at hk, just like before. So the center right here on this one is the origin. Now, we're going to have b squared plus c squared equals a squared. So it looks a little bit different than the Pythagorean theorem, but it's the same concept going on here. And what each of these is going to represent is that c is going to be our where our foci are at. So let's put one right over here and put one right over here. So whatever the length from here to here is, that's what we're going to be considering C. So if it is going from the origin out to the foci on the left, that would be a distance kind of of negative C, and to the right of positive C. And again, distance isn't negative, but if we were finding this coordinate, it would be negative C, comma 0. And this coordinate over here would be C, comma 0. So out C distance. So go ahead and get rid of that negative. Now our vertical axis on this one, the shorter axis, or sorry, the shorter distance from the midpoint, or sorry, from the center to the edge. The axis is the entire length there. But from here to here, let's call that our B value. From the center to the edge, that's going to be B. So I can find out that this coordinate right here, again, if it's going from the origin of 0, 0, then this coordinate here is at 0, B. Because it hasn't gone left or right at all, just gone up B amount, and down here it's going to be 0, negative B. And those two distances squared, so B squared, whatever it is, plus C squared, whatever it is, gives us the distance from the center to the edge all the way over here to this vertex. So we got that length there. That'll be our A value. It is at A, comma 0, and this one over here is at negative A, comma 0. And it will be whatever B squared plus C squared. It'll be that amount. It'll be the square root of that total, what A is. So let's kind of put that into practice in the next couple of videos. But here we are, and hopefully you notice that, again, this is kind of like how radius was over here, and this is kind of like how radius is over here, but it's just been elongated. It's been stretched out a bit. If it's going vertical, if it's more of a vertical ellipse, then all those things are going to still be true, that whatever this value here is on your minor axis from the center to the vertex here, squared and then to your foci, that amount squared will be equal to the center to the vertex up here, your longer one. All right, go ahead and read through this next section right here. I won't read it to you, but we'll go ahead and start putting some of this stuff into practice in the next video. All right, I hope that helps.